Hello friends, in today's question, three objects A, B and C are kept in a straight line on a frictionless horizontal surface. These have masses m, 2m and m respectively. The object A moves towards B with a speed of 9 meters per second and makes an elastic collision with it. Thereafter, B makes completely inelastic collision with C. All motion occurs on the same straight line. Find the final speed of the object C. So we have A, B and C. So the collision between A and B is perfectly elastic, and between B and C it is perfectly inelastic. So let us consider the first case. For A and B, the collision is perfectly elastic. Okay. So we say collision between A and B is perfect elastic. Therefore, let us write the various combinations for velocity as well as masses. We say before collision, velocities are for A, let us suppose given as UA, for B, let us suppose that is given as UB, and after collision the velocities are for A it is VA, and for B let us suppose that is VB. So we can use the conservation of momentum, as it is perfectly elastic. You can say conservation of momentum. The mass is given as, let us suppose, MA, UA plus MB UB is equal to MA VA plus MB VB. And initially it is given that UA is 9 meters per second. So UA is given as 9 and UB is our 0 and MA is M and MB is 2M. We substitute these values, we get 9M plus 0 is equal to MVA plus 2M VB. So this M cancels throughout. So we can write this equation as VA plus 2VB is equal to 9. Let us call this equation number 1. Now using conservation of energy, you can say that half M A UA square plus half m BUB square is equal to half m AVA square plus half m BVB square. And once again, if we substitute these values, we get this as half into m into 9 square plus 0 is equal to half m VA square plus half into 2m VB square. Once again, m cancels out throughout. Therefore, we get this equation as VA square plus VB square is equal to 81. Let us call this as equation number 2. So we solve equation 1 and 2. You can say using equation 1 and 2, we get VA will be coming as minus 3 meter per second and VB will be coming as 6 meter per second. So we are here now interested only velocity of B, because block B is going to strike now block C. So next is collision between B and C is perfect inelastic. And we assume, okay, and perfect inelastic means that after collision B and C are going to stick together and move together. You can say therefore B and C will move together with same velocity. So we can draw figure also. So this is our 2m and we have m. So this is block B and C. We have this as before collision and this as after collision. They are going to move together. So B and C, you can say after collision. So we can say as it is perfect inelastic, so using conservation of momentum, see conservation of momentum, we get this as MB VB plus MC VC is equal to, they will be moving together, so this will be twice M B plus MC multiplied by VC. So we substitute the values, we get 2m VB, we already know VB we calculated as 6 plus 0 is equal to twice m plus m into VC. So m cancels out, so we get this as 2 into 6 is equal to 3 times VC, or we can say VC will be coming equal to as this will be 3.2 and this will be 4 meter per second. So This is the velocity of object C. This is the velocity of object C. So this completes the question. Thank you.